Hello friends, welcome to Silan Software. I have brought this video about linear regression. One point in machine learning. So linear regression is one type of supervised machine learning algorithm based on the concept of regression. Regression meant for continuous value or numerical value. That means when a problem statement is given, if the outcome is a numerical value, a continuous value, so we will implement linear regression algorithm. So I will give the clarity by taking an example. Little bit point about linear regression that you have to know, especially the minimum point. So equation for linear regression is, see, no doubt it is a supervised machine learning algorithm. Supervised machine learning meaning is what? What is supervised machine learning? Y equals to f of x. Y means dependent or target or output variable. X is independent or input variables. That means by taking the input variables, we will get the value of y, or we will find the output variable value. So here variable means we will consider a data set. So containing data set is containing so many columns. Okay, so here one column or more than one column I will consider as my input, and one column value I will consider as output. So in this context, the equation for linear regression is what? Y equals to mx plus c or mx plus b, whatever. So what is y? So y represents what? The dependent variable. The dependent variable or output variable or target variable, whatever you can understand. Y is this. What is x? Uppercase x. So it is representing independent variables or input variable or input variable. So what is m? M representing what? The slope. M is the slope of the line, because y equals to mx plus c. It is representing a straight line. So the slope of the line. Slope of the line means what? So how much y is changing for a unit changes in x. Unit change in x. That means what? For one unit changing in x, then how much unit y is changing? If the x value is changing 1, then how much the value of y is changing? So that is the slope. And what is c? So this is the intercept. The intercept. So what is the meaning of intercept? When the value of x is 0, then what will be the value of y? The value of y, when the value of x is 0, that is representing what? Intercept. So simple equation I wrote, that is the linear regression equation. Y equals to mx plus c. Y is the dependent variable or output variable, x is the independent or input variable. Okay, so m is the slope. What is the meaning of slope? For one unit changing in x, then how much y is changing? So intercept means x is 0 when what will be the value of y. Okay, so if I will visualize, this is suppose some data item in x-axis, some data item in y-axis, some data items. Okay, so a best fit line, so some data points, so it is representing what best fit line. I'm not going to the mathematics behind this context because I will show you what practically that means. We will create a linear regression model and we will consider an example based on the problem statement. So our model is predicting. So that predicting answer we will see and how far it is accurate that we will observe. So problem statement is what? First of all, we will go to problem statements. So I hope till now everybody got clarity. Linear regression is a supervised machine learning algorithm based on the concept of regression. If the outcome is a continuous value or numerical value, so we will go for linear regression algorithm to implement. Suppose this is my small data set. Now, one column is area and one column is price. So here some data is given. 2600 square foot area price is 5 lakhs 50,000. 3000 square foot area price is 5 lakhs 65,000. 3200 square foot area price is 6 lakh 10,000. 3600 square foot price is 6 lakh 80,000. 4000 square foot area price is 7 lakh 25,000. So if this is my data set that I will consider, then my problem statement is, my question is, what will be, what will be the price? What is the price of 4,500 square foot area? Okay. So here input X is 4500. This is my independent variable. And here, one column I will consider as input, definitely area column, and price column, that is, I will consider as output. So here input is 1. By taking one input, one column as input, the model will predict the value of price. So that's why we can say it is a simple linear regression. Simple linear regression and multiple linear regression. If one column I will consider as input, that is simple linear regression. If more than one column I will consider as input, that is multiple linear regression. In my next video, I will give the clarity about multiple linear regression by taking an example. Okay, so now I will go to my Google Colab environment. Okay, so first of all, I will import libraries. Import libraries. So whatever the libraries that we have known, so the library I will import. That is import numpy as np, import pandas as pd, import for visualization matplotlib dot plot as plt, import cburn as SNS. So first I imported NumPy, Pandas, Matplotlib and Seaborn libraries. Okay, so then we will go to create a data frame. Okay, so this file name is landphrase.csv file. So I will bring this .csv file into my Google Colab environment. So guys, you see how I am bringing. So here I will click here and you see go to this section, file section. Again you click here and go to this. I will click upload to session storage. So I will go to where I have kept the dataset. I have kept in A drive my dataset folder, and the file name is landphrase. Select, then click on open, click OK. So in this way, landphrase .csv file that I brought into my Google Colab environment. Now my next step is I will create a data frame. Create a data frame. And we know that how to create a data frame by taking a CSV file. Let my data frame name is df equals to id dot read underscore CSV function. So read underscore CSV function is a built-in function. When it is invoking by pandas alias pd, it is returning a data frame, and within bracket, within parenthesis, I will specify the CSV file name. So that file name is, you see, landprice.csv. Landprice.csv. Okay, so I can print data frame. Let my data frame name is df. Okay, so in this way, first I created data frame, and you see in my data frame df, area is one column, price is one column. So this is zeroth record, zeroth. So index is generating. So this is first record, that is zeroth index record, one index record, two index record, three index record, four index record. Okay, so first of all, we created a data frame. Then very simple things. There are five number of records. Df dot save keyword representing what? The number of rows and the number of columns. Five number of rows and two number of columns. Then a data frame dot info function I will call for getting information about my data frame in detail. So one function I am invoking, that is info function. I will hit run. It is a concept of pandas. And you see the detailed information about the data frame df that we got. So there are five entries, that means 0 to 4 index column, and column is area column, price column, non-null value, that means there is no null value, and area column values and price column values are which type of data item it is containing. Int 64 types of data items. Okay, that's the memory. So overall, we got information in detail about the data frame by invoking info function. Similarly, if you want to get some statistical information, so I will call describe function. Describe function. Okay, now I will hit run. You see, so I got some statistical information. So in area column, so count value is this, min value, standard deviation value, minimum value. 25 percentage values are less than from this value in area column. Similarly, 50% values are less than from this value in area column. 75 percentage what values are less than from this value in this column, and this is the maximum value. Same way we can understand for the price column. If I will write dot 3 representing transpose. So in this way, it will display. So area column count, mean value, standard deviation value, minimum value, 25%, 50%, 75% are less than from this value in area column and price column. So this is the maximum value. So in this way, so we got some statistical information about the data frame. Similarly, for checking missing values, checking null values or missing values, so what I will write the line. So which function I will call is null function. Data frame name dot is null function. Is null function returning a boolean value true or false. So if true means there is a missing value, if false there is no missing value. So if I will add a sum function, so it will calculate column wise and find the sum whether this column having missing value or not. If I will hit run, you see area column 0, price 0. That means area column having no missing value and price column having no missing values. So these are very simple things and common operations in every algorithm. Okay, safe keyword, info function, describe function, checking a missing value, very common steps in every what supervised machine learning algorithms that we will do. Now, by taking the area value and price value, we can visualize also. So we can create a plot, create a scatter plot. So we can create a scatter plot to visualize the area value and what price value. So for creating a scatter plot, first of all, I will call x level function. In x-axis, which information that I want to specify, let area in square feet. So similarly, plt dot y level function, x level function, y level function, all are built-in function coming from pyplots. That's why it is invoking by pyplot alias plt. So I can write a price. So how to create a scatter plot? So there is a built-in function scatter. So that built-in function I will call by the PLT. So dot scatter. So scatter function is also another built-in function coming from pyplot module. So it is invoking by pyplot alias PLT. So definitely when we are creating a plot, we need some data items for x-axis and data items for y-axis. So here I can write data frame dot area. So this is for what for x-axis. So data frame df dot price. Consider I will consider for what y-axis, and color equals to one color I'm specifying. Let color equals to red, marker equals, suppose I will indicate star. Then to display the plots, I will call the show function. Okay, so in this way, I created a scatter plots. I will hit run. So y level, y level, y level. Okay, you see, so this is my plot, this is my visualization, and you see, so mark is what marker. So I had given star. So 2600 square foot price is this, 5,50,000, 3,000 square foot price is this, and 3,200 square foot price is this, 3,600 square foot price is this, and 4,000 square foot price is 7,25,000. So by taking what area in square foot value in x-axis, price value in y-axis, so we created a plot and it is representing visualization. It is representing data visualization. And through this visualization, we can observe. So 2,600 square foot price is how much? 3,000 square foot price is how much? In this way, we can observe. So this is all about data pre-processing. Now we will go to create a linear regression model. Then how to create a linear regression model? So I will create the linear regression model. Okay, so we have three points. We have to create a model. Then after creating the linear regression model, we will train the model. Once the model is trained, that means model is becoming intelligent. So once the model became intelligent, then the model will predict over or by taking our input value. So artificially we are creating model here, linear regression model we will create. Then model is trained. That means model is becoming intelligent. Hence the term artificial intelligence. Okay, so first of all, we will create a linear regression model. So linear regression is a built-in class, and this class I will import from sklearn library in machine learning context. So one library that is very important for machine learning. Without sklearn, machine learning is what meaningless. Practical work we cannot do. So from sklearn, sklearn is a library or module in Python context. We can say dot linear underscore model. So linear underscore model is a sub module. From this, I am importing linear regression. So linear regression is one built-in class name. You see L is first character is uppercase or first character the next word is uppercase. Single word, and it is a class name, built-in class name. And linear regression class coming from linear underscore model. It is a sub module of sklearn. Sklearn is a module we can say, or it is a library we can say. Okay, library means container containing so many built-in functions, so many built-in classes. So now I will create an object of a linear regression class. In Python, how to create an object? Object name equals to class name parenthesis. So let here object name, whatever I will give the name, let my object name I will give the model equals to class name linear regression, then parenthesis. Now this linear regression object, that is model object name is. So this object is representing what? Creation of a linear regression model. Now I will hit run. You see now linear regression model I created. So linear regression object I am creating. So that linear regression object representing linear regression model. Then after creating the linear regression model, I will train the model. So how to train the model? There is a built-in function fit function, and the fit function I will call, but fit function coming from linear regression class. That's why it will call by linear regression object, that is model. So again, I am repeating how we trained the linear regression model. For this, there is a built-in function fit function. So the fit function coming from linear regression class, that's why it is invoking by linear regression object. Here linear regression object name is model. So that's why I am writing model.fit. Then there is a protocol within fit function. So two things I will specify. One is input and one is output. So input is my area column and output is my price column. So you remember one protocol in not only here in inter machine learning context, when input variable we are specifying, so it will represent in the form of multi-dimensional array. One subscript one dimensional, more than one subscript multi-dimensional. So I can write area. So this point you remember. So in entire machine learning context, So when the input variable I am specifying, so that input variable I will specify in the form of multi-dimensional array. So one subscript one dimensional, more than one subscript is multi-dimensional. This is the protocol for input variable presentation. But for output variable, no protocol. So I can write simply df.price. So now I will hit run. So you see, in this way, the linear regression model became intelligent, became trained. So once the model is trained, so definitely model will predict. So definitely model will predict by taking input value. Predict by taking input value. My input value is 4500. So like fit function, there is another built-in function, predict function. That function is also coming from linear regression class. That's why it will call by linear regression object, that is model dot predict. So within predict function, definitely I will represent the input value. Input value currently I was telling, always I will represent in the form of a multi-dimensional array. So in this way, I will present the input value. Now I will hit run. And you see, this is you await this part. This is the warning part. Just you see the prediction value is 7,91,660. That means the 4,500 4,500 square foot area price is what? 7 lakhs 91,660. Okay. So this is the prediction value. Our linear regression model predicted. Now we will get clarity. We can what implement or we can uh, okay, so we can find the slope and intercept value and x value to already given 4500. So just check we will check by what, through our equation y equals to mx plus c. So first of all, I will find the slope model. My linear regression object is model dot. So there is a keyword for getting the slope. COEF underscore. I will model dot COEF underscore the keyword. So I will hit run. Now this is my slope value. I will get the slope value. Means what? This is M. Similarly, how to get what mx plus b or mx plus c intercept. Okay, so get intercept value. So for this model dot, there is a keyword intercept. Intercept underscore. Now I will hit run. So I got this value. Now I will put, okay, y equals to mx plus c, y equals to m. So this is the value of m. So I will put here mxm into x is 4500 plus c. So this is the value of c. Okay. So what is the value of y? So you see, same value 7,91,660, and the model predicted 7,91,660. So in this way, we got clarity what the model predicted, and by going through the equation what we got. The same output is coming. For better clarity, if I will visualize this prediction value, so if I will get a straight line or if I will get a best fit line, then model prediction is 100% correct. Now, so already scatter plot that I have created, first of all, this line, just I am copying first this line. So I copied first scatter plots. Then I am creating a simple plot. There is a plot function. If I will call a normal plot, it will create. So by taking the f dot area column value and prediction value. So who is predicting? Model is predicting. What is the name of the model? That is model dot predict. Okay, model dot predict. I can write taking the area value. Okay, so just color, I am changing color equals to let blue. Okay, so in this way, so here model dot predict function here, one parenthesis we have to give, then this. Okay, so now I will call show function for displaying the plot. Now I will hit run. You see one straight line we are getting. So this is my best fit line. So hence, whatever the linear regression model we created, so that is accurate, and whatever the linear regression model predicted the price value, that is 7,91,660. So that is correct. So the value, the price value of 4,500 square foot area is 7,91,660. Okay, so I hope everybody got clarity. This is all about simple linear regression. Okay, a small project that you will consider. In my next video, I will give the clarity about multiple linear regression. Here, one column we consider as input. When more than one column I will consider as input, that will represent multiple linear regression. In my next video, I will show you by taking an example. Okay, so I hope everybody got clarity with linear regression, especially simple linear regression. Thank you.